So, hello everyone. My name is Ionuț Baltariu, and today I will present how cybercriminals are exploiting the employment market through malware traps that are hidden in fake job offers. So, first of all, I'd like to mention some details about me. I'm a software engineer and technical lead at Bitdefender, based in Romania. And at Bitdefender, I'm involved in the development of digital identity protection products, while also working on internal automation tools. My latest interests are directed in the areas of social media threats, such as account takeovers and malvertising. And last but not least, I'm an author on the Bitdefender blogs, having contributed to articles in which we analyzed the streamjacking phenomenon and various malicious advertising campaigns. Is the mic all right? Yeah, perfect. So, we will start by offering details about the job offer scams, while also giving an example of a malicious hiring offer. And then we will take a high-level look on the embedded coding assessment, continuing with the deep dive into the infection chain, which involves multiple techniques and programming languages. And in the end, we will find out who are the threat actors, but you got a spoiler from our colleague here. And we will see what are the conclusions of our research on this topic, while also leaving, I hope, some time for the Q&A. So, first of all, what are these job offer scams that I'm talking about? So, they are attempts to infect developers with malware while portraying as recruiters or hiring managers on various platforms such as LinkedIn, Upwork, Fiverr, and a lot more. And in this process, developers receive coding assessments that hide complex malware within simple code. So these projects usually are often gathered from open source or public projects. On this slide, we can observe 3 examples of LinkedIn posts in which users mention that they have either been contacted or were actually infected by the malware that was hidden in the coding assessment. So just by simply searching about this kind of a scam, you can get the idea of how common this phenomenon has become lately. And as a tangible example of a compromise attempt, I will present my interaction with such a recruiter. And in the screenshots on the right, you can see a so-called offer, which is very generous. So it's a remote job and it's paid like in cryptocurrencies or from $85 per hour upwards, which sounds really good at the first peek. But the hiring process is presented afterwards. And as a first step, I had to send my resume, followed by a test, so the coding assessment, a technical interview that's never really happening, and it ends with a meeting with the CEO. That's always never happening. So we can say that we don't know of what company this CEO would be, since the message is probably you've seen it's very generic, and the name of the product would be DEX platform, so that's decentralized exchange platform, without mentioning any company. Also, the English doesn't seem to be that of a native speaker, which would be expected given the recruiter's name. Another detail that might be of interest in some cases is that the offer mentions a position on the front end, although personally one could understand from my LinkedIn page that I have no relevant experience in programming in this subdomain. So, from what we have seen until right now, most of the malicious job offers mention a job in the crypto industry. And we believe that this is on purpose and has the goal to maximize the malicious gains that the hackers will have, since we will see later that the delivered malware also includes a stealer that targets crypto wallets. Besides the CV review, the recruiter asked for my GitHub, which I omitted on purpose on the CV. And furthermore, the question about my projects or contributions makes sense, as we will soon see that the malware is hidden within forked public or open source projects. So as a final step, I received a Bitbucket repository that represented the part of the code on which I would work, and the feedback document that was also provided, which had to be completed with answers to some specific questions. So lately, this year, these so-called recruiters would also include Figma projects, so Figma designs, to make the interaction seem more genuine. And we can already see from the structure of the Bitbucket link that it's not credible. And it has a vague name, so you see u_dex. And it also has a seemingly random user there called VT3mox. And under normal circumstances, neither the username or the project name should belong to any serious company. The structure of the projects sent by the rectors respects a pattern. So, as I've mentioned, the usernames and the repository names are always vague or kind of random. And in this particular case, we can see that the last commit was done on the 3rd of February, and it affected all files, which can be quite atypical. And all projects that we have seen until right now were written in JavaScript or TypeScript, and we're using some runtime such as Node and other well-known tools such as NPM. So, taking a closer look at a malicious repository, we can observe that the attackers take over already existing projects. The commit highlighted in red, so the first one from the top, was made on 14th of January of 2025, officially by an unknown author with an email address that is likely stolen or disposable, and it introduced malware in the code base. So there are changes made in a multitude of files so that the malicious code is not that easy to find, but I got an example here in which we can see that the malicious JavaScript code which is injected in the repository, so that's the next.config.js file. And the last 3 commits were made by a new author on dates that are relatively close to the ones of the real author. One interesting fact here is that the email address belongs to the Washington University, and that's really making us think that the attackers are most likely using compromised accounts to make changes to like this. Another interesting detail is the fact that the day in which the change was made is different from the so-called author date, and this was certainly done to offer a slight credibility when someone briefly checks the commit history of the projects. In some cases, the commit history might not even be available, as the attackers just create a new repository with code that they have copied from other sources. Going back to the document attached to the coding assessments, we can figure out that it is not wished to only do a code review, but to actually run the code in order to observe how certain animations or functionalities work. And personally, I have not run the code or analyzed the runtime of the project to check whether the questions actually have any sense. I think they do. And as I was already having the context, I have continued with the static investigation of the malicious code. But before we do a deep dive on the malicious code, I'd like to ask you a question. And could anyone tell me if there's anything out of place on this slide? You raise your hands or... Okay. So there you go. You see a slider on the bottom side. From my point of view, it's totally unexpected. Especially that at the first view, you don't see any code that's over the width of the editor. And this could only mean that there are pieces of code that are hidden in the file. So, if we have a little patience when using the horizontal slider, we can observe that the obfuscated code was hidden without any issue. So that's just simply obfuscated with obfuscator.io. I think it's an open source tool, but we'll see some examples soon. So that was I'd say, static way of putting malicious code in the repository. This can be quite easy to detect. So the next thing that they have done was they started to do it dynamically. So in both examples, the code is loaded from a third-party API that is controlled by the attackers. However, one of them uses a so-called error handler, you can see in the code, to conceal the malicious intent, while the other, the bottom one, directly uses eval. So if you see eval in JavaScript code, you already got the idea that it's malicious, but if you look at the first snippet, well, I wouldn't say you directly catch the malicious intention from the start. So, on this first example, the API, which goes to this host, so chainlink API v3.cloud, would just respond with a 500 error code, so that would be a server error side code. It would respond with a 500 error on purpose, and it makes the code go on the error branch. So this is where it would use the error handler function. And the definition for the function can be seen on the right side. And we can see that it dynamically creates a function with the code that has been received from the API. So the way that it works, it responds with the 500 error codes, but inside the payload of the request, you actually have the malicious code, and then the malicious code is dynamically injected into a JavaScript function that executes later on. Lately, the threat actors also used simple ASCII decoding algorithms. So instead of seeing domains in plain text like these ones, they would just do ASCII arrays. I know it's easy to decode, but on a first look, maybe some detection mechanisms wouldn't catch it. And one particularly common domain that is used is the api.endpoint.io. You can also see it here, which is a public service that can be used to serve JSON. So in this case, threat actors are actually using public resources to deliver malicious code. We concluded that the JavaScript loader is either carefully hidden in the source code, as you've seen with the horizontal slider example, or just obtained dynamically and executed from third-party domains controlled by the attackers. And after we deobfuscated the code, it was absolutely clear that it is malicious. Inside it, we found browser-specific locations as well as identifiers, so IDs of, 32 characters, I think, for browser extensions. That are corresponding to mostly crypto wallets. So just by seeing that array of 20 or so IDs that are of crypto-related extensions, you get the idea that something malicious is going to happen. And moreover, the loader downloads another file that it executes. So the attackers construct the command that executes another malicious script based on the operating system. You could see that on the first if. So obviously W comes from Windows. And what it does, it just starts another Python process from the command line, but it also does it for Linux in this case. Good. In some newer versions of this specific loader, we cannot really state that the code is malicious at the first look, as the hackers have added supplementary obfuscation layers by using both base64 and other simple encoding algorithms. And in any case, the behavior is identical. So after you manually reverse the script, let's say, you end up to the same malware that we've seen before. And the loader has a double role, so it also steals browser information, but it also executes a Python script that basically continues the infection chain. Taking a step back, regarding the malware variants that might be spreading through this campaign, there are lots of them. And it is safe to say that the threat actors are constantly changing their payloads. And in this presentation, we are going to only talk about Beavertail and Invisible Ferret with the bonus of the Tsunami malware. However, recently the threat actors have started also using what is called Other Cookie, which is at its 5th version or so. And it could be summarized as a mashup between Beavertail and Invisible Ferret. And other samples include Golang Ghost, Pylang Ghost, Ratatouille, and Other Candy. Going back to our Beavertail and Invisible Ferret flow, the malicious JavaScript files also download and start a Python loader, which has the sole purpose of, again, downloading other malicious Python scripts and executing them. One common thing that is consistent with all these Python files or scripts is that they are obfuscated in a similar manner, and some scripts have an additional layer of self-decryption using XOR algorithms and base85 decoding, but all have a recursive base64 decoding step. And depending on the decoded script, there can even be 50 intermediary layers until the true source code is reached. The techniques of the attackers change as time passes, and we have observed changes on the self-decoding algorithm in order to avoid early detection. However, there are some scripts that have been used repeatedly in this malicious process, and we will discuss them in what follows. The first example script is named pay.py. This comes from, I'd say, payload.py. And it is the most complex one. It collects information about the system on which it runs. It acts as a keylogger, an info stealer, and it also configures multiple backdoors depending on the operating system. So that could be any desk, for example, for Windows, or reverse shell for Mac and Linux, and so on. And depending on the exfiltrated information, it is likely that these backdoors are used to continue the malicious process. Just imagine the case in which the device of a company gets breached because an employee took an interview for another company on it, let's say. So this could lead to the extraction of company secrets, or just can extend the malicious process to other devices on the company network. As example functionalities, we can see on the script on the left that the malware gathers the internal and external IP of the victim, and on the right we can see how it checks the keyboard events and copies the clipboard whenever certain key combinations are pressed. You can get to explore these in the end. I will share a VirusTotal collection with you, so if I go too fast, maybe you'll have the opportunity to check them on VirusTotal. So furthermore, the script downloads additional resources, as we can see with the /ADC route, on the attacker control domain, and after downloading and executing the resource, which is related to the AnyDesk software, it sends a message to the C2 through a socket mentioning the operating system and the get AnyDesk words. Another specialized script that is repeatedly found in these kind of attacks is the one that targets web browsers. The script exfiltrates information that is specific to the browsers that the victim uses on any operating system. And moreover, sometimes it acts just like a loader for what the attackers call the tsunami injector. So on this slide, we can see the classes that the attackers have come up for every operating system on which the malware might run, mostly Windows, Linux, and Mac OS. And the stealer specializes in Chromium-based browsers, such as Chrome, Opera, Brave, Yandex, and Microsoft Edge, and it contains relevant paths for every major operating system. The malware has the capability of decrypting values that are protected in the realms of Chromium browsers, such as login data or credit card information. And these two select queries are actually done on the SQLite databases that the browsers use in general to store information. So the first one would grab credit card data, such as name, expiration date, and the encrypted card number, while the second one retrieves the login operation that the user has done on the browser. And the encrypted card numbers or encrypted data in general could be basically decrypted using the function like the one you see on the screen. I've just mentioned that the browser stealer might also contain an embedded malware called the tsunami injector. And on the snippet found on the right side, you can see that the payload is run under the name Runtime Broker. That's a fairly common name on Windows, I think. And the executable is, of course, downloaded from a domain controlled by the attackers, but the process to obtain the actual link is rather interesting. So in the code, there are 1,000 XOR encrypted pastebin URLs that might or might not contain the URL at which the malicious executable can be found. And the malware goes through all of them until it finds and downloads the malicious executable. The malware that the tsunami injector downloads and executes is a multi-stage .NET application that uses a Tor command and control endpoint. So it communicates with the threat actor infrastructure through Tor. It downloads a Tor proxy that then is started on port 9050, along all HTTP requests to be passed through this node further on. And the malicious part is downloaded actually after the Tor proxy setup, and it's without a doubt a capable multi-purpose malware, as all malicious modules run within separate threads. So, as expected from the threat actors that we will soon name, but you already know about them, a cryptominer module that mines Monero and Ethereum exists. It's capable of doing dynamic throttling based on the hardware resources that are available, so CPU, GPU, and RAM. And it also looks for the user activity. So, for example, if a full-screen application is detected as running, the miner will auto-limit itself in order to not raise any suspicion. So if you go and play a game, the miner turns itself a bit more quiet in order to not make you suspicious, to check Task Manager and so on. But if you would check Task Manager, or just use Process Explorer, Procmon, and so on, it would just suspend its execution. So it would be harder to find that it's even running. It also has a keylogger module. So this one is capable of silently capturing and storing keystrokes. And this enables the agent to exfiltrate secrets that are not stored anywhere in the system. So that would be private conversations and much more. The last two modules are the configurable so-called secret file stealer and the backdoor. So the behavior of the secret file stealer can be controlled by a configuration file that is obtained, again, from the command and control endpoint that is reached through the Tor protocol. And for example, we can see in this configuration in which the stealer is enabled. Yeah, so this would be this flag. And it also scans for documents, pictures, and so on, while also ignoring certain directories using wildcard strings. So funnily enough, it ignores the Euro Truck Simulator directory for some reason. I have no clue why. Maybe it has something to do with what files are present in the game, but if you got any idea, just please reach out to me. And it also misspells hand gesture recognition. And by also looking at the wildcard comparisons, we can observe that the words also target specific languages besides English, such as Spanish and French. And you can see most of the words here on the last part. So to sum up, let's just go again through the whole infection chain. So first of all, the victims are being contacted on LinkedIn by fake recruiters. These imposters mention that in order to get hired, you have to complete a coding assessment. You have then the project on GitHub, Bitbucket, GitLab, or any other repository. And then if you run the project, the backend typically uses a Node.js as a runtime, and we've actually seen that the malicious JavaScript file is either hidden somewhere, like in the case of the slider that I've shown you, or just loaded from a third-party website. The malicious JavaScript also acts as a stealer, or rather a rudimentary one, I'd say, but it also starts a Python process in the background. So this Python loader downloads, again, multiple scripts. I've shown you two, but there are cases in which there are 3 or perhaps even more or less. And one of them might optionally include the tsunami loader. This particular infection chain is rather complex, and it includes multiple techniques that complete each other. So, the malicious samples that I presented today were named Beavertail and Invisible Ferret. Beavertail is the initial loader hidden in clone projects that have been modified by the attackers. And the Invisible Ferret refers to the Python scripts that have the multiple malicious functionalities. So the techniques, malware families, as well as the C2 servers that we found out in the example scripts were attributed to the Lazarus groups, or APT38. And furthermore, we could absolutely say that the crypto mining, cryptojacking behavior is consistent with the North Korean modus operandi. So these activities align with the broader objectives of the regime of evading international sanctions and generating revenue for itself, especially for funding weapons development, government operations, operations like these ones, and so on. The campaign that I have detailed today is known as Contagious Interview, but it also has other aliases, and one is given by ESET, that's Deceptive Development. So even though it's analyzed since December 2022, and I'm sure there are lots of attempts before that, the phenomenon is constantly evolving. So the samples are becoming more and more advanced, while the threat actors adapt to basically any technology that is of their interest, or to any detection that the security providers put on their samples. So it's a continuous cat and mouse game, I'd say. In conclusion, we can say that Lazarus and all affiliated subgroups, because it's not specifically Lazarus, but certain subgroups of the organization, they evolve in a continuous manner in order to not be detected by security providers. In the last year, they have started to actually host interviews. So you would get the message, you would get the details, but you would also end up on an interview with someone. And in that interview, they would put pressure on you to execute the code. So if you don't have any security measures before that, you would end up maybe pretty unknowingly executing malware on your computer. Moreover, they have been experiencing with developing malicious npm packages. So instead of downloading the code from the repository, you would see nothing malicious on the code, but when you start the project, it would install some npm libs, and those libs would contain malware. And furthermore, another report by Cisco Talos, this is recent, it's from the last week, has shown that they also use Visual Studio extensions. So instead of having npm libs or malicious code, they would just require you to install certain Visual Studio Code extensions so that you could run the project. And in those extensions, of course, that you find malware. And the last thing, Anthropic reported that these North Korean hackers were using generative AI products to basically add new features to their malware. So they are constantly evolving with a greater speed now in the AI age, I'd say. We can absolutely say that spreading information about these job offer scams might save potential victims from future hacks, while skepticism and double checks could always prevent a malware infection disaster. So, for you, I have a bonus. It's not malware, I promise. It's not a coding assessment. It's not anything like that. The first one is a link to the Bitdefender blogs article, which I wrote about this campaign. The second one is a sample collection on VirusTotal. You'll find some samples there. Some of them are pretty old, are from the start of the year. But if you look on the description of the collection, you'll find some Bitdefender detections that you can search on VirusTotal if you have an enterprise account, and you will see lots of more decent samples, I'd say. And on the bottom side is my LinkedIn if you wish to connect. So, thanks for your attention, and any questions if we have time. If not, we will move on to the next presentation.
I guess we can do questions while the next speaker gets mic'd up, if you need a mic. Okay, so if you go to that, we'll see if there are a few questions meanwhile. We do have questions.
Yeah, quick question. Do you know why they switched to Python for the infection? Why not just stick in Node?
So they started with Node that loads Python, but funnily enough, they recently they moved fully to JavaScript. So I've mentioned some families. Otter Cookie and Otter Candy, I think, are fully using JavaScript. I would just say that they are experiencing with lots of different languages and techniques, so they see which one works the best, which one is more evaded by them for the antivirus providers and so on. So I don't think they really have any specific reason for switching to and from a language to another.
So from the opposite perspective, from a legitimate recruiter that wants to, let's say, get people to join the company, what kind of things they can do so that they seem like a legitimate recruiter with a, let's say, legitimate process?
Yep. So perhaps my screenshots, most of you maybe were already suspicious from the start when you were seeing the descriptions and all the vagueness and the Bitbucket generic repository and all that. But as I've said, they rather evolved in the last period. So they actually give you Calendly links to select intervals to give interviews. They actually land on those interviews. I'm not sure if they use AI to maybe deepfake their videos or voice and so on, because you would rather, I guess, see someone from North Korea trying to give an interview for you. They included Figma projects when presenting the project to you, so even more advanced uses of AI for generating project descriptions, for generating projects. So I think they are already becoming pretty genuine, and the best thing that you could do to avoid this kind of situations is just to be extremely skeptical and run everything in controlled environments. Hope I answered the questions.
It was more on the side of HR looking to recruit people. What are the kind of things that you can do so you seem like a legitimate recruiter?
Okay, so what could real people do so they are not mistaken for North Koreans in this case?
Exactly.
Okay, just use the image of your company, use official. If you have any official coding repositories, make sure they are tied to the company, and you really not pressure anyone to be executing code on their computer so that they become really suspicious and suspend the whole interviewing process. So I'd say that being really humane and having really official links, information, and no one should do the trick. Thank you. I'm sorry for going too much on the first answer.
Thank you, Ionuț.